Hi everyone. So here's another short Chord theorem proof, and I've done other videos on Chord theorem. Well, another video with two other proofs and a demonstration on GeoGebra. So I just thought I should show this third way to prove the Chord theorem, and well, this is how it goes. Okay, the Chord theorem states that angle between the tangent to a circle, the chord drawn from the same point of contact, is equal to the angle subtended by that chord in the alternate segment. So the diagram goes like this. We have circle center O. A is on the circumference, and we draw a chord AB and another chord BC, join A and C. Then we have G outside the circle and draw a tangent from G to F. So we have GBF as the tangent now. Okay, then what we're required to prove is that the angle ABG is equals to ACB, and then we have highlighted them over here with blue, and then this is the color I'm going to be using for ABG and ACB, and then you'll see that we prove that they are equal in the end. Okay, so to prove we will draw a diameter BE, or a diameter from B, and it goes to E, and then we join E and C. Okay, then here next what we'll say OBG is 90, radius perpendicular to tangent. So you can see here our radius is perpendicular to the tangent. Then this means that our angle, blue angle that we are supposed to prove, is equals to 90 minus this red angle here, ABE. Okay, then we go to this triangle here, we say ECB is also 90, it's angle in the semicircle. Then we see that this ACB here would be 90 minus this angle here. Okay, now we just need to show that these two red angles are equal. So but we see that ACE is the same as ABE. You see the bow tie, so there are angles in the same segment. So you see the nice little bow tie here, red bow tie. Okay, so since we've proved that these two red angles are equal and the blue angles are each equals to 90 minus the same, or angles of equal measure, then it means they must also be the same. And that concludes the proof. So that's what we proved here quickly. So it's a very nice and short proof. And now let's go to GeoGebra and see what's going on. So again, here in GeoGebra, we see the same thing. The red angle here equals to this one, since ABC is the chord that is making the red angle. So the angle between the tangent and the BC, then BC in the other segment gives this angle E here. Again, this side, the blue, we see CBF being the angle between the tangent and the chord, and then that chord subtends, the chord BC subtends that angle A over here. There's another chord theorem happening here. Angle here, if we look at BE, then BE means this angle here will also be equal to that one here. Again, if we look at chord with this ABG, which is what we proved, then this C here will be equal. So I think maybe let's just find the measure angle and measure our angles. Let me see. Okay, there's this angle, and then this angle is supposed to be the same as this one here. And indeed, this 36.72, and we also have 36.72 here. And then if we have this angle here, this gives us 43 point. I'll check what it is later. Then let's see the angle that AB subtends. And then we have an angle over here. Let me just go back to that. It's 43.3. And we also have 43.3 here. We have 36.72 over here. And 36.72 over here. So many different ways to demonstrate the theorem that we just proved. So you can see over here we have so many angles that we can show this alternate segment theorem. Okay, so many ways to see the tan-chord theorem here. So we have three chords coming to the point of contact, which means we will have three angles that relate to them in this theorem. So if we're looking at chord BE, we get the angle between the tangential chord is this one, and then we have 54.77 here, and we have 54.77. Again, this chord BE has an obtuse angle on the other side, but it won't be subtending anything on this side, so we can talk about that. Then if we look at the blue one, we're looking at the tangent and the chord will be chord BC. Then the blue gives us this 99 angle here, 99.33. And then on the other side of the same chord, we have the red angle. It's between the tangent and the chord BC, which means BC subtends this red angle here. So yeah, it's all happening at the same time.